Welcome to part one of our lesson that describes how to enhance the extensibility of Java's Completable Future framework by integrating it with the virtual thread mechanism available in Java 19. The hooks for enhancing Java's Completable Future framework were actually added in Java 9, which enhanced the Java 8 Completable Future framework with new methods that support custom executor implementations. You can take a look at the link at the bottom of the slide for more information about other features added to Completable Futures in Java 9. We'll start with the default executor method. This method takes no parameters and returns an executor. In particular, it returns the default executor that's used for other methods in completable futures, such as the completion stage methods that don't explicitly specify an executor. Next, we'll also take a look at the new incomplete future factory method, which again takes no parameters and it returns a completable future. And the completable future that it returns will be returned by a completion stage method. And this allows subclasses of completable future to override new incomplete future to customize the particular details of a subclass of completable future that provides the appropriate custom characteristics. And the third method we're going to talk about is called complete async. This method takes a supplier and returns a completable future, and it will complete the completable future asynchronously using the value that's given by the supplier. When all these three methods are combined together, we get a very powerful technique. So let's take a look to see how we can actually customize the completable future framework to use Java virtual threads by default. This particular example is available in the EX5 project in my Loom directory in my live lessons GitHub repository. So we'll start by taking a look at the completable future EX class, which extends completable future. And as usual, we apply customization using inheritance. There's no other way to take control, no other portable way to take control of how the completable future framework behaves other than to subclass it as we're showing here. Next, we go ahead and define a private static variable called sexec. And this particular executor by default will create a virtual thread per task. And we do this by using the new Java 19 executor's new virtual thread per task executor factor method. And that's the type of executor we're creating. Next, we go ahead and override the default executor method we looked at earlier to return the executor that we want by default, which in this case will create a new virtual thread for every request that's being processed, instead of using the Java comment fork join pool, which is the default behavior. Next, we override the new incomplete future factor method. And this is the factor method that creates the actual concrete subclass that we are going to be allocating here. In this case, you can see that that will be an instance of completable future EX. And then finally, we implement a new static method called supply async, which has the same signature as the one that comes out of the box with completable future. And what this is going to do is it's going to allow us to submit a supplier that will be run asynchronously using a virtual thread in this default implementation. And you can see the way this works. We make a new instance that's an instance of completable future, and then we go ahead and call complete async on it, and we have the complete async method arranged to run the supplier in the default executor, which again in this case will allocate a virtual thread per request. Now, if we wanted to be able to override the behavior of the default executor, we could define yet another method, which would be a setter method or a mutator method that would take the new executor and replace the one that was defined here by default, which is the virtual thread per task executor. So that's the end of part one of our lesson. In part two of the lesson, we're actually going to walk through the source code to demonstrate how all these features can be applied in practice.